Hey guys, still looking at sequences and series, and today we're going to look at sums and series. So a series is listed below. Given the infinite sequence, so a sub 1 and a sub 2 and a sub 3 all the way up to a sub n, or if it's infinite, it keeps going, dot dot dot. The sum of the terms, meaning we just add them together. Notice I've taken the commas away and I've replaced it with a plus sign, is called an infinite series. And then a partial sum is the sum of the first n terms, to where we just say, okay, a sub 1 plus a sub 2 plus whatever is in there till we get to a sub n. And we also call that a finite series. And we denote this as a capital S sub n. So with that being said, let's just look at an example. Okay, so here I have a sequence, and it is showing that it's an infinite sequence. Okay, so in the example, what it says is find the partial sum. So for the first one, it says S sub 2, meaning n equals 1 and n equals 2. So I can look up here, and this is where n equals 1. This one will be n equals 2, n equals 3, n equals 4, n equals 5, n equals 6, and so on. So for S sub 2, that is the first term plus the second term, which gives me a negative 2. And for S sub 5, well, that's the first 5 terms. N equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So I take these 5 terms and I sum them together, and I get the value of 5. So for the other two, this is S sub 3 and S sub 7. 3 and 7. Find the partial sums for these two. And after you find them, let's compare our answers. Alright, so for S sub 3, I have the first 3 terms. I'm going to have 1, negative 3, and 5. 1 plus a negative 3 plus 5. And all I do is add those together. Negative 2 plus 5 is 3. And for S sub 7, well, I'll even show you a shortcut before we actually do it, is that I've already calculated up here S sub 5, and it equals a 5. I could simply say, okay, well, that's just S sub 5 plus what's left, a negative 11. And see, it doesn't give us anything else out of there, but I can see how it's going, plus 13. And that gives me this value for S sub 5 is simply 5. I calculated that up here, so that's 5. Whenever I do the math here, I get a 7. Or I could have, instead of doing that, I could just simply write all these out. 1 plus a negative 3 plus 5 plus a negative 7 plus 9 plus a negative 11 plus 13. And then added them together. So that's whenever you're asked to find a partial sum. The other way that we do summation is with sigma notation, and this is sigma, this funny looking E. And what this says is the sum, there's sum, as k goes from 1, there's my k equals 1, to 4, there's my 4. So the sum as k goes from 1 to 4 of 2k plus 1. K is called the index of summation, and the index of summation does not have to begin at 1. We could have said k equals 4 and take it to 8. But it gives us a means by which we can articulate mathematically where we want the sum. So again, sigma notation, this means sum, to add together. The sum as k, there's k, goes from 1, that's where we're starting, k equals 1, 2, 4 of 2k plus 1. So let's look at an example of that. So here we have the example, find and evaluate the sum. And what I have is I have the sum as k goes from 1 to 5 of 1 over 2k. And what I do is I replace k with 1, 2, 3, 4, and 5. Where did I get the 1, 2, 3, 4, and 5? K goes from 1 to 5. So I'll have 1 over 2, instead of k, I'll write a 1. And then 1 over 2 times 2. And see, if you notice, in red I have each one of these numbers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I do the multiplication. This is what I end up with. I end up with 5 fractions. I know, and then you have to find the common denominator because you got to add them all together. So, but this is my answer right here. 137th over, or 137 over 120. Okay, so what I would like for you guys to do is pause the video, and I want you to work this one. Practice what it says. You can see an example of it right here. Practice what it says, say it to yourself, and then think about how you're going to set that up. Alright, so the first thing that we're going to do, let's talk the nomenclature. The sum, or sigma, the sum, as k goes from 1 to 5 of a negative 1 to the k power. So what I'm looking at, and I can do like this, I can, above this I'll write each one. K equals 1, k equals 2, k equals 3, k equals 4, and k equals 5. So whenever k is 1, that's going to be a negative 1 to the first power, plus whenever k equals 2, it's going to be a negative 1 squared, plus a negative 1 to the third, that's when the k equals 3, plus a negative 1 to the fourth, plus a negative 1 to the fifth. Negative 1 plus 1 plus a negative 1 plus 1 plus a negative 1. Even powers, they become positive. Odd powers stay negative. My answer, negative 1. And that is sigma notation and taking sums. Okay guys, critically think and structure your homework. Watch those publishers' videos, and good luck on your remaining homework problems.